everybody, I'd like to talk to you about odd, even, or neither for functions. And this is a really interesting topic for me. I quite like doing these types of problems, trying to figure out if a function has symmetry or if it's odd or even. And it's really quite nice. We could do it in several ways. And that's the beauty of mathematics, is that it is so flexible. So we're going to just use a function. I'm going to call it f of x. So f of x is a function. I'm going to show you 3 examples. And the rule for if you know a function is even is you're going to replace every x that you see in the function with negative x. And after you have simplified the function, if there's absolutely no change to the function after you've simplified it and it looks originally like the f of x, then you know that it's an even function. Whereas a function is odd, you're going to do the same thing. You're going to replace all the x's with negative x, but if you get the opposite of your original function, then you know your function is odd. And that would be like the algebraic representation of whether or not you know a function is odd or even. And just as a reminder, there are plenty of functions out there that are neither odd nor even, so watch out for that. Here's the first example that we're going to use. So we have an f of x equals an x cubed minus 16x. And if this goes pretty fast because I have the writing on a fast mode, you can always stop it and try this slowly on your own and then start it when you're ready. So I'm about to replace every x inside of this function, it's a cubic function, with a negative x, and then I'm going to go ahead and see what happens. So the first thing I'm going to do is I'm going to look at this function and put a negative x everywhere that I saw the original x, and now I'm about to simplify it. And notice I use the parentheses. I am very careful to use the parentheses when I substitute, but negative x in the quantity to the third power ends up to be negative x cubed. And then the negative 16 times the negative x, that's going to end up to be a positive 16x. And so I get that function, and that function looks a lot like if I took the original function and I made the opposite of the original function. Like, for example, if I multiplied the original function by negative 1 on both sides, I also get the same thing, negative x cubed plus 16x. So I know that f of negative x is going to be the same as the opposite of f of x. And that's really how I know this function is going to turn out to be an odd function. So if I replace all the x's with negative, and I get the opposite of the original function, so I know that I have an odd function. Okay, let's look at the second example. This time I have f of x equals 2 times the absolute value of x minus 4. I'm going to do the same thing again. I'm going to replace every x with negative x. Okay, and notice in absolute value, negative x in absolute value is the same as x in absolute value. So I end up with really the original function. So by replacing every x with negative x, nothing happened to the function. I got the original function back. So again, when we replace all the x's with negative x and there's no change to the function, then I know that this function is what I call even. If I tried to test if it were an odd function and I took the opposite of the function, multiplying the function by a negative, I would get negative 2 times absolute value of x plus 4, which is not the same as f of negative x. So notice it's not an odd function. Negative f of x is not equal to f of negative x. So that's a test, and it failed that test. So it's only even, and it's not odd. Okay, so the last function example I have is I have f of x equals 3x minus 5. That's a linear function. It's going to graph a line. I'm going to replace every x with a negative, and notice I get negative 3x minus 5. Now this isn't the same as the original function. So f of x is not the same as f of negative x, which means that this guy is going to be not even. And if I negate the original function, they're also not the same. So the negation of the original function, negative 3x plus 5, is not the same as negative 3x minus 5. So it's not odd either. So this function is what we call neither. It's neither odd nor even. This also could be explained graphically. So the first cubic function graphs what looks like this. It's got 3 roots, 1 at 4, negative 4, and 0. And notice that if we reflect on both the x and the y axis, we hold the x axis, we flip it, they hold the y axis, and we flip it, the graph's going to look exactly the same. If this is hard for you, you can just turn this upside down, which is the same as reflect on both axes, and the graph will look exactly the same. And so this is what we call symmetric on the origin. So all odd functions look exactly the same once you turn them upside down, like exactly. And so if we look at the example number 2, that was an even function. This guy will look exactly the same with a reflect just on y. And so what we call this symmetry on the y. All even functions have symmetry on the y. So if you can flip it just on the y and it looks exactly the same, then it's an even function. If you can turn it upside down and it looks exactly the same, then it's an odd function. So symmetry on the origin or symmetry on the y. But the last function, which is just a linear function, that guy right there doesn't look the same on a reflect on the x and y or on the origin, and so it's neither. It won't give you the same exact graph either way. And finally, this can be true of really any function. So if we look at the trig function like cosine, this guy right there, if we look at the trig function sine, if we look at a hyperbola, and if we look at maybe a circle of radius 4, we can ask ourselves, will this look the same if I flip it on both the x and the y, or just on the y, or will it not look the same at all? And so for the cosine graph, if we reflect just on the y-axis, it will look exactly the same, and we call that even. For the sine graph, if you do 2 flips, one on the x and one on the y, it will look the same, and that's what we call an odd function. If we do a y equals 1 over x, our hyperbola, it is also an odd function. It'll look the same for 2 flips, or if you turn it upside down. And the circle is actually interesting because it is both even, you can flip it on the y, and it's odd, you can flip it on the x and the y, but it's not even a function, okay? So, but it does have the symmetry there. All right, hope that helps. Thank you.